Welcome to International Definition. My name is Kenneth Freelain, and I'm going to be your host for today's edition of International Definition. Today on International Definition, we're going to feature the engineering tribute to the Presidential Inauguration of January 20th, 2013. Today, we're going to receive some information about the North American Water and Power Alliance. The North American Water and Power Alliance was conceived in the 1950s by the United States Army Corps of Engineers. Certain projects were called great projects, and one of the great projects involved the development of more water resources for the United States. The planners envisioned the diversion of water resources from some rivers in Alaska south through Canada by way of the Rocky Mountain Trench and other routes to the United States. And the entire project would involve 369 smaller and separate construction projects. The water would enter the United States through northern Montana. There, the water would be diverted to the headwaters of rivers like the Colorado River and others. The water would generate hydroelectric power as it passed through dams. The water supply would double the total amount of fresh water available to the lower 48 states, with its major focus being on the western states. This would solve the water shortage problems of the West for the foreseeable future. The amount of water available would in fact be so great that some water would be left over for use by Mexico by way of the Colorado River. By the way, today, the Colorado River is significantly depleted as it enters Mexico. The United States Army Corps of Engineers has studied this project in the late 1950s and in the early 1960s. This project was very close to realization. Washington State Senator Scoop Jackson was a significant sponsor. Senator Jackson was a person who believed in this project. The project was opposed by public sentiment in Canada. Recently, there has been a resurgence in the effort to implement NAWAPA, the North American Water and Power Alliance, as a result of the activities of Lyndon LaRouche and his LaRouche Pact. Now, let's watch a video which will provide us with some additional information about this proposed engineering project.
By utilizing 22% of the runoff of these rivers in British Columbia, approximately 40 million acre-feet per year is added to the runoff collected, bringing the total to 97 million acre-feet a year for all the reservoirs formed by these 10 dams in British Columbia and the 7 dams in Alaska and Yukon. After connecting with Babine Lake and Stewart Lake, about 30 miles west of Prince George, the collection will enter a man-made canal and be diverted 2 ways. In the most impressive demonstration of the efficiency of the continental approach, the geological defile, known as the Rocky Mountain Trench, makes it possible to complete the remaining 500 miles of storage reservoirs in the north with only 4 new dams, one dam about 1,000 feet tall at the headwaters of the Fraser River, and 3 other dams averaging 350 feet tall. Of the 97 million acre-feet a year collected, roughly 60 million acre-feet a year will enter a pump lift system beginning 30 miles north of Prince George and be lifted up 670 feet into the Rocky Mountain Trench reservoir, requiring 6.8 gigawatts of power. The remaining collection, not already used for coastal hydropower further north, will then drop into the Fraser River, generating power for the pump lift. By preventing a portion of the flow of 4 rivers in Alaska and Yukon, and 6 rivers in northern British Columbia from becoming saline, a permanent, renewable source of rainwater will cycle through the inside of the continent, and by effect, greatly augment the runoff of existing rivers in the southwest, tripling available stream flow from 32 to 104 million acre-feet a year, as well as create a new underground river system connecting 30 newly created reservoirs throughout the southwest. Out of the Sawtooth Reservoir at 5,250 feet, a 50-mile-long tunnel through the Sawtooth Mountains emerges into a 640-foot-wide, 350-mile-long concrete-lined canal near Littlewood River Reservoir, accommodating a flow rate over twice the average flow of the Snake River. This canal will wind its way through southern Idaho, passing 10 miles from American Falls Reservoir and crossing into the Great Basin just before crossing through the tip of Utah and into Nevada, where a 100-square-mile reservoir will be formed, with a storage capacity of 7.3 million acre-feet, over one-fourth that of Lake Mead. A natural depression between Murdoch Mountain and Bald Eagle Mountain on the border of Utah, 50 miles east of Elko, Nevada, will be filled to an elevation of 5,000 feet. Out of this reservoir, the canal will continue before branching two ways near the city of Trout Creek, Utah. The eastern branch is the central southwest delivery corridor, bringing 48 million acre-feet a year to three basins and northern Mexico, and will begin by connecting with the existing Sevier Bridge Reservoir in Utah and making available 2 million acre-feet a year for irrigation in the area. A canal delivers the water out of Sevier Bridge into a tunnel under the Wasatch Mountain Range, transferring the flow from the Great Basin into the Colorado Basin. The outflow from this tunnel will be into a reservoir between the North Caneville Mesa and the San Rafael Reef, formed by two dams in the Muddy River Valley in south-central Utah, the uppermost near Tomish Butte, and connected to a reservoir between the Caneville Reef and Caneville Mesa, formed by a dam in the Fremont River Valley. The combined storage will be 6.3 million acre-feet, or one-fourth the storage capacity of Lake Powell. Continuing south, the flow will create two more reservoirs in the Capitol Reef Depression and the Escalante River Valley, totaling 1.8 million acre-feet of storage capacity, before crossing Lake Powell via 45 miles of tunnel and siphon and entering Arizona about 20 miles east of Glen Canyon Dam. From here, the main southwest delivery aqueduct connects through a 45-mile tunnel to a large reservoir 40 miles northeast of Flagstaff and 2 miles south of Tuba City, formed by an 800-foot dam on the Little Colorado River. The lake thus formed by a single dam will be roughly 6,000 square miles and average 330 feet deep, yielding a storage capacity of 128 million acre-feet, nearly 5 times the size of Lake Mead. In addition to the main southwest corridor supplied from this central reservoir, a smaller diversion will serve southeastern Arizona and Sonora, tunneling out of Little Colorado Reservoir 45 miles southwest into Oak Creek Canyon, located 5 miles northwest of Sedona, dropping to form a reservoir with a capacity of 1/2 million acre-feet, before continuing through an open canal and meeting with the Verde River, 30 miles from its headwaters. A dam east of Pine Mountain will form Verde Reservoir, held at 3,000 feet, with a storage capacity of 2.4 million acre-feet, alone more than doubling the storage capacity of Arizona's Salt River Project, before exiting Verde Reservoir through a 25-mile tunnel to provide additional water for the Salt River Project's Roosevelt Lake, 80 miles from Phoenix. Where the Big Chino Wash River meets with the Verde River, another tunnel of 50 miles will intersect the mostly dry Hassayampa riverbed, 10 miles north of Wickenburg and 30 miles south of Prescott, creating a reservoir there of 0.7 million acre-feet storage, and another further south down the Hassayampa riverbed. Tunneling west under the Gila River, 3 more reservoirs of 1.3 million acre-feet storage within 50 miles from the border of Sonora will be formed, delivering water for irrigation in southeastern Arizona, and crossing into Sonora with an aqueduct, delivering roughly 2 million acre-feet a year. Returning to the main southwest delivery corridor, a lift out of the Little Colorado Reservoir will allow the water to flow by gravity through a series of 5 reservoirs into southeastern Arizona and western New Mexico, before crossing into the Rio Grande Basin. The first is a reservoir at the confluence of the Black and White Rivers, formed by a dam at the headwaters of the Salt River near the junction of Carrizo and Cedar Creeks. The Black River Reservoir will have a storage capacity of 7.2 million acre-feet, over 1/4 the capacity of Lake Mead. Crossing into the Gila River Basin, 2 smaller reservoirs are formed by the Southwest Aqueduct Tunnel and Canal System, each tunnel roughly 15 miles long. The first, formed by a dam on Eagle Creek River, 20 miles from its confluence with the Gila River, and another on the Blue River for a combined storage of 3.4 million acre-feet. Having delivered in total 12 million acre-feet a year of renewable supply to the state of Arizona, providing for the irrigation of 2 million acres without pumping costs, the tunnel system at 5,000 feet continues, crossing into New Mexico and delivering 30 million acre-feet a year. 2 more reservoirs are created in the Gila River Basin. First, on the San Francisco River just east of Brushy Mountain, 30 miles from its confluence with the Gila River, and second with the dam on the Gila itself, 70 miles from its headwaters, located 20 miles northwest of Silver City, New Mexico. The combined storage of the Gila and San Francisco reservoirs will be 21.7 million acre-feet, nearly equivalent to that of Lake Powell, and will divert water south to farms along the river in New Mexico, before continuing south to supply a major aqueduct into Sonora, delivering roughly 7.5 million acre-feet a year to the state, and providing for an increased irrigation of 184%. With the combined reservoirs in Utah, Arizona, and New Mexico, the storage capacity of the Colorado Basin will increase from 61 million acre-feet at present to 174 million acre-feet, nearly tripling. In order to cross the Continental Divide and pass from the Colorado to the Rio Grande Basin, water is pumped out of Gila Reservoir and brought east through a tunnel under the divide, where a large amount is diverted into the Rio Grande River, serving Las Cruces, New Mexico, before continuing south along the border. The rest is routed across the Rio Grande River, pumped a second time, and brought through a tunnel under the Sierra Blanca mountain range, before emptying into the Pecos River Valley, where a large storage reservoir will be formed by a dam on the Pecos River and held at an elevation of 4,000 feet. With its northernmost point being just south of Fort Sumner, and its southern point 30 miles from Roswell, it will be roughly 600 square miles, having a storage capacity of 34.8 million acre-feet, serving as the central distribution reservoir for all irrigation along the Pecos River districts near Roswell and Carlsbad, New Mexico, and the entire length of the river through West Texas, as well as 2 million acre-feet a year pumped north into Colorado. Together with the water diverted from Gila Reservoir into the Rio Grande and from the Pecos Reservoir into the Pecos River, roughly 21 million acre-feet a year will be delivered to Rio Grande Basin's irrigation districts of New Mexico, West Texas, Chihuahua, Coahuila, Nuevo Leon, and Tamaulipas, nearly twice the mean discharge of the Colorado River's 11 million acre-feet a year. Pumping costs will be eliminated, farmland restored, and an estimated 12.5 million acres of crops irrigated, over twice the current total of all the states involved, including the entire state of Texas. Due to utilization of the continental topographic characteristics, the power needed to pump the water along the Southwest Delivery Aqueduct from Little Colorado Reservoir into the Pecos River Reservoir will be generated by the opportunities for gravity flow along the side branches in Arizona and New Mexico, generating a net surplus of power. The western branch of NAWAPA 21's delivery system continues from the diversion at Trout Creek through a tunnel before exiting into a lined canal and forming a large reservoir 50 miles from Las Vegas, in a natural depression in the Sheep Mountain Range of southern Nevada, north of Hayford Peak, having a storage capacity of 7.1 million acre-feet, over one-fourth the size of Lake Mead. Out of Vegas Reservoir, one branch will deliver water west to provide water to the irrigation districts of California's Panamint Valley and adjacent valleys, and another aqueduct runs south, roughly paralleling the Colorado River, generating power and providing water to the irrigation districts in southern Nevada and California before supplying the existing lower Colorado irrigation pool near Yuma, Arizona. An aqueduct through Baja California will deliver 4.3 million acre-feet a year to the state, crossing through Mexicali before being pumped and tunneled to the western slopes of the Lagunas Mountains, creating 5 reservoirs in total. Tunnels will connect these reservoirs to the existing Morena and El Capitan reservoirs in Southern California near San Diego. Eastern and Southern California will receive a total of 12 million acre-feet a year from these routes. Additionally, an increase of 15 million acre-feet a year to the system could serve an extension, beginning with a pump into the Chutes River, delivering 5 million acre-feet a year to Oregon, and 10 million acre-feet a year to Lake Shasta and the Owens Valley in California, increasing the total renewable supply for California by 22 million acre-feet a year, or 26%. In summary, the renewable water supply of the Rio Grande Basin will be increased by roughly 300% and storage by 174%. The Colorado Basin's renewable supply will increase by roughly 150%, an increase of storage capacity by 285%. The Great Basin supply will increase by 44% and gain a freshwater storage of 14.4 million acre-feet in a basin characterized by salt lakes. With all of the above plans implemented, there would be an estimated doubling of the currently irrigated farmland from 21.88 million acres to 44.38 million acres as a permanent potential in the Southwest, and with zero pumping costs for the irrigation. In addition to these direct effects, nonlinear multiplication factors will take place due to added moisture in the region, affecting precipitation trends and creating a vast increase in plant and animal life. The NAWAPA 21 Authority will engage in land cover programs for the directed use of water to encourage preferred climate trends. Returning to Canada, a major addition to the main storage route described integrates with the proposed development of British Columbia and supplies the Canadian prairies with needed water. Peace River runoff and other Mackenzie Basin streams, as well as potential flows from the runoff of the north, would make possible a 730-foot wide barge canal across Canada, stretching from the man-made Lake Williston, created by BC Premier William A.C. Bennett, all the way to Lake Superior. Sufficient water supplies will be drawn from the canal for the needs of Alberta, Saskatchewan, and Manitoba, and a branching barge canal will cross through the Dakotas and link up with the Missouri and Mississippi river systems, designed for flood control as well as for shipping and irrigation. The seaway will stabilize the levels of the Great Lakes when excess water is available. Branching off from the canal, a seaway between Lake Winnipeg and Hudson Bay, and a canal between Georgian Bay and James Bay, would create cheap transport routes for resource development. The extension of waterways into areas where existing access is achieved only by expensive overland transport will open vast new areas to accelerated settlement and development. Barge traffic connecting Lake Williston to a navigable Fraser River through locks near Prince George would make British Columbia an inflection point for Pacific Ocean trade and allow for material processing within the province, making use of the extensive 32 gigawatts of surplus hydropower possible through the system. These and other direct benefits, in addition to the sale of a resource currently wasted, outweighed the effect of flooding 2.5% of the total land area. For the efficient construction of the NAWAPA 21 reservoirs, canals, pumping and power stations, the completion of the Alaska-Canadian rail system, studied under former Alaskan Governor Murkowski, is immediately available for construction during the design, pre-construction, and site preparation phases of NAWAPA 21. 2 routes from Dease Lake to Fairbanks and Fort Nelson to Fairbanks will neatly service their construction and supply. During the period of construction of NAWAPA 21, Alaska and British Columbia will break away from the status of raw material exporters and begin processing their own resources, becoming self-sufficient with local industries and new supplies. The system's dams, tunnels, canals, locks, pumping and power stations will alone require 27 billion cubic yards of earth moved, 3 billion cubic yards of concrete, and 440 million tons of steel. The estimated machine production and material production for the construction machinery on site, as well as the system components, will require 4 million jobs. Additional rail supply lines from a revived Midwest manufacturing belt throughout the West, and those lines running to the north, new power stations, and the new industries required for the task will increase this number by millions more. With modern technologies, the NAWAPA 21 design presented here could be done as fast as labor and plant capacity can be allocated for the task, in as little as 15 to 20 years. In addition to those benefits stated, numerous other benefits will result. There will be an increase in national income from agriculture, livestock, mining, and manufacturing. An overall increase in land values will result in irrigated land, while related industrial and urban land values will increase in proportion. Recreational activities will increase with the formation of scenic and navigable waterways. The increase in commerce and industry will be tremendous. Tax receipts of the 3 nations will rise, and each country will reap gains in foreign exchange by the yield of increased exports of agricultural, forest, and mineral products. The process set into motion by the project will serve as the basis for a restoration of the public credit system, with a functioning system of bank lending for productive economic activities. Making the decision to enact NAWAPA 21 will create a new generation of productive citizens, making good on our debt to the World War II generation, on whose productive wealth we have too long relied and left nothing for the generations to come.
I'm glad that you were able to join us for today's edition of International Definition. Today on International Definition, we examine the North American Water and Power Alliance, also known as NAWAPA. We did this as a part of the engineering tribute to the Presidential Inauguration of January 20th, 2013. And now, until our next broadcast, I'm your host, Kenneth Freelain, thanking you for joining us today.